All right, so hopefully you took a minute, you read through the problem, that's what I did, and then after reading through it, I copied down the key pieces of information, and now I'm going to work through it to be able to answer question A. So for part A, it says write the equation of a tangent line of h at time t0. So we should know that the equation of a tangent line is y minus y1 equals m of the tan x minus x1. And then what we're going to do is we know that the x's are kind of like my t's. So my x1 is 0, my y1 is 91, given that initial condition that we were told in the problem. And then we need to find m tan. Well, this equation right here represents the slope of the tan. So dh dt is equal to negative 1/4. The h value isn't 0. That was one of the most commonly made mistakes on the exam. The h value is 91. So you get 91 minus 27. And then you divide that value by 4. So you get negative 16. So to find the equation of my tangent line, you get y minus 91 equals negative 16 x minus 0, which is y equals negative 16x plus 91. So if you are delving into what does that mean, well, what that means is that the initial temperature of the potato was 91 degrees, and it is decreasing at negative 16 degrees for every, and I guess instead of x, we would use t. They wouldn't dock you for that, but to be consistent, it would mean every 16 degrees, it goes down for every minute. So then it says use the equation to approximate the internal temperature of the potato at time t equals 3. So y of 3 would be negative 16 times 3 plus 91. And when you plug that in and simplify, you get 43. And the units on that is temperature, because again, it's asking us to approximate the temperature at a time. So it would be 43 degrees Celsius at 3 minutes. So again, the internal temperature of the potato at 3 minutes is about 43 degrees Celsius. All right, for part B, it says use the second derivative to determine whether your answer in part A is an over or under estimate of the internal temperature of the potato. So first thing we're going to do is find that second derivative. So d2h dt squared is equal to negative 1/4. And then you have to take the derivative of the inside. So the derivative of h is capital dh dt. Derivative of negative 27 is 0. And then what we have to do is substitute dh dt in from the previous problem. So we take negative 1/4 and then we plug into it negative 1/4 h minus 27. Negative times a negative is a positive 1/16 h minus 27. So the second derivative is a positive function that is linear in a sense. So what we want to do is then talk about what is happening for that point. So when is h greater than 27? So if h is greater than 27, then our time is greater than 0 always. So that would be like a positive and a positive. So if the second derivative is positive, then we know that it is concave up based on our chart for derivatives. So a positive second derivative tells us that the original is concave up. So if the graph is concave up, it would look something like this. And then what we want to do is talk about the fact that it is positive. So if it is concave up and positive, then our approximation or our tangent line will always be below the graph. So that would mean that this is an underestimate. So your answer in a well thought out or written sentence would be that since h of 27 is positive and t of 0 is positive, then d2h dt squared is positive and h is concave up at time t equals 3. Therefore, my answer is an underestimate. And for the last part, it says for times less than 0, an alternative model would be used to determine the internal temperature, and that's the function g. So we have dg dt is equal to negative g minus 27 to the 2/3, where g of t, so that's the original, so we're given the derivative and we talk about the original. So g of t is measured in degrees Celsius. So g of t is equal to degrees. Okay. And we are also told that g of 0 is equal to 91. So it says find an expression for g of t based on this model. So in order to find an expression for g of t being given a derivative, we're going to find the antiderivative. So essentially we are going to integrate, but we can't integrate it the way it is now because we have mixed variables. So we got to get the g's to the g's and the t's to the t's. So we're going to take dg dt equals negative g minus 27 to the 2/3. And we're going to get the g stuff with the dg's and leave the negative behind. So you get 1 over g minus 27 to the 2/3 dg equals negative dt. And then we are going to find the antiderivative of that. So in order to find the antiderivative, we have to kind of think of that 2/3 as coming up as a negative. So you have g minus 27 to the negative 2/3 dg equals the antiderivative of negative dt. And the inside is a u value, so we're going to do u sub, so u equals g minus 27. And then we're going to say that du equals the derivative of that, so derivative of g would just be 1. Derivative of 27 would be 0. So the derivative would just be dg. So du equals dg. So we can substitute that out. So this is kind of like a u to the negative 2/3. So we take our antiderivative by adding 1. Our antiderivative, we would add a power back to 2/3. So you get negative 2/3 plus 1, which is 1/3. So you get g minus 27 to the 1/3 all over the new power, which is 1/3, equals negative t plus c. So 1 over 1/3 is 3. G minus 27 to the 1/3 equals negative t plus c. Now we want to solve for c, and we'll use our given condition of g of 0 equals 91. So we have 3 times 91 minus 27 to the 1/3 equals 0 plus c. 91 minus 27 is 64. The cube root of 64 is 4. So 3 times 4 is 12. So my c value is 12. And then what we're going to do is just kind of write this out as a problem now. So we have 3g minus 27 to the 1/3 equals negative t plus 12. And then what we're going to do is work backwards to solve for g. So divide both sides by 3. And then to get rid of the cube root, we cube it. And then add 27. So, to find an expression for g of t, we would have to separate our variables, antiderive, find the constant of integration using an initial condition, then rewrite the equation using g and t for this problem. The last part, yeah, we're not done. This was worth, I believe, like 5 out of the 9 points on this problem. The last part says, based on this model, what would be the internal temperature of the potato at time 3? So the last thing we're going to do is find g of 3. So 27 plus 27 is 54 degrees Celsius. So the internal temperature of the potato at 3 minutes is 54 degrees Celsius.